Assalamu alaikum wa rahmatullah. Today, inshallah, we're going to talk about Unit 2. It's about powers. It's not strange, you take it before, recite before. So we're going to take the same things, but we are just going to add the negative power. We're just going to add the negative power. The name of the unit. See, Unit 2, as we said, it's a non-negative and negative integer powers in R and the operation on them. Of course, we know that the number consists of base and power. I'm going to say a power of m. A is a base and m is a power or exponent. So the rules that I have that we studied before: number 1, a power of m times a power of n equals a power of m plus n. In multiplication, we add powers if they have the same base. In multiplication, we add powers if they have the same base. Number 2, a power of m divide a power of n equal a power of m minus n. In division, we subtract the powers if they have the same base. Number 3, ab all to the power of n equals a power of n times b power of n. We're going to distribute the power once over a, then over b. Number 4, a over b all to the power of n equals a to the power of n over b to the power of n. We are also going to distribute the power over a and over b. Number 5, a power of m all to the power of n equals a to the power of m n. And this time we're going to multiply the powers together, m multiply n. Now the new thing that we're going to take, number 6, a power of negative n. If we have a negative power, it doesn't affect the number, it just will affect the base. It will be, if it's a numerator, it will be a denominator. Yani a in here is a numerator, it will be 1 over a all to the power of n. It will be 1 over a all to the power of n. I will just, to cancel the negative, I will put the number in the denominator. And by the same way, if it's 1 over a power of negative n, it's in the denominator now, I will put it in the numerator, it will be a power of n. What about if it's a fraction? A over b all to the power of negative n. I will find the reciprocal. Okay? It will be b over a all to the power of n. I will just switch the numbers, the numerators and the denominator. For example, if I have in here root 3 all to the power of negative 4, it means 1 over root 3 all to the power of 4. I just put root 3 in the denominator. It will be 1 over distribute 4 over the power, distribute the power over the base. It will be 1 over 9. Another example, 1 over negative root 3 all to the power of negative 3. As I said before, that negative in the power will not affect the sign of the number. Okay? So 3 in here is an odd number. The odd number will leave the negative as it is. It will not affect the negative. That's it. Now, that negative in here will make the denominator a numerator. So it will be root 3 all to the power of 3 equals negative 3 root 3 now. This 3, if I'm going to solve it with the base, it will be 3 root 3. Rule number 7. If a power of m equals a power of n, then m equals n. If I have in here two bases are equal and the numbers are equal, then the powers are equal. Then the powers are equal, such as root 2 all to the power of x equal to root 2. Then root 2 all to the power of x equal 2 root 2 in here equal root 2 all to the power of 3 equals root 2 all to the power of 3. Okay, then x equals 3. Then x equals 3. If the bases are equal, then the powers are equal. Number 8, it's the last one. If a to the power of n equal b to the power of n, then a equals b. And the same way, if the powers are equal and the numbers are equal, then the bases are equal. For example, if x power of 5 equals 1 over 32, then x power of 5 equals 1 over 2 to the power of 5, and x power of 5 in here equals 1 over 2 all to the power of 5. From here, x will be equals half. How can we know that 32 equals 2 power of 5? We will factorize it. This is 32. Factorize it. Divide by 2, 16. Divide by 2, 8. Divide by 2, 4. Divide by 2, 2. And divide by 2 equals 1. So it's in here 1, 2, 3, 4, 5. So it's equal to power of 5. Example, page 29. If x equal root 3 over 2 and y equal 1 over root 3 and z equals root 2 over 2, find the value of x square plus xz all to the power of 2 times y to the power of 2. Just substitute each value in each place. X to the power of 2, it means root 3 over 2 all to the power of 2, plus xz, it means x times z, so it will be root 3 over 2 multiply root 2 over 2 all to the power of 2 multiply y to the power of 2, يعني 1 over root 3 all to the power of 2. Solve each expression alone. Root 3 over 2 all to the power of 2. Distribute the power over the numerator and the denominator. So it will be root 3 to the power of 2 equals 3 and 2 power of 2 equals 4. Plus the first one in here is root 6 over 4 all to the power of 2 multiply 1 square equals 1 and root 3 square equals 3. Then it will be 3 over 4 plus Root 6 square, it will be 6, and 4 square equals 16. Multiply 1 over 3. Simplify. Divide by 2 equals 3. Divide by 2 equals 8. Simplify again. Divide by 3 equal 1. Divide by 3 equal 1. So I have in here 3 over 4 plus 1 over 8. You can do it using your calculator. Okay, I don't have a calculator here, so I'm going to work it mentally. 3 over 4 times by 2 and times 2. Numerator and denominator, it will be 6 over 8 plus 1 over 8 equals 7 over 8. This is number 1, page 29. Number 2, find solution set for each of the following equations in R. 3 over 5 all to the power of x plus 2 equal 125 over 27. Number 2, 3 over 5 all to the power of x plus 2 equals 125 over 27. I need to make these two sides are the same in the base or in the power. In the base or in the power. There is nothing to do with the left hand side, so I'm just going to work with the right hand side. 125 over 27. Okay. If we don't know what to do about them, we will factorize them. We will factorize them. There is 125 divided by 5 equals 25, divided by 5 equal 5, divided by 5 equal 1. And the same with 27. Divided by 3 equals 9, divided by 3 equals 3, divided by 3 equals 1. So I have in here 5 power of 3 over 3 power of 3. I can take 3 as a common, so it will be 5 over 3 all to the power of 3. And the other side, it's 3 over 5 all to the power of x plus 2. Are they the same? No, they are not. The numerator in here is the denominator on the other side, and the denominator in here is the numerator on the other side. So I just need to switch them. How to switch them? It will be 3 over 5 all to the power of negative 3 equals 3 over 5 all to the power of x plus 2. If the bases are equal, then the powers are equal. So I have in here that x plus 2 equals negative 3 sent to the other side. So x will be negative 3 minus 2 equals negative 5. So the solution set equals negative 5. This is number 2A. This is number 2A.